Okay, class, this will be kind of a quick touch on the basics of a monomial. We're studying polynomials this chapter, so we have to first learn what a monomial is before we can figure out how to work with polynomials. Right here, it's pretty clear to see the definition. It says a monomial is a number, a variable, or the product of a number and a variable, and one or more variables with whole number exponents. Product is the key word in that sentence, because if you look at the examples of the tables here, on the left hand side we have things that are monomials, on the right hand side things that are not. Now this one right here, we have some rules of monomials, and we'll just go over these here in a second, but it says the degree of a monomial is the sum of the exponents of the variables in the monomial. So if we look at this, when we look at the exponents of the variables here, well, there's no variables, so any constant would be a monomial technically, and its degree would be 0. If we look at this, so if you look at any constant number as 0, the 3 would have a 0 and the x would have a 1, so the degree of this one would be 1. Again, 1/2 is 0. A is going to be a power of 1. B is going to be a power of 2. So this all counts as one monomial term, and we add those up, 0 plus 1 plus 2, and this is going to give us a degree of 3. This last one, negative 1.8, again, it doesn't matter what it is, decimal, fraction, what have you. That term's degree is going to be 0. And then m is to the 5th power, so the degree of the whole term is going to be 0 plus 5, which is 5. So we just talked about it. I didn't put it in the blank there, but the degree of a non-zero constant term is always going to be 0. Examples of things that are not monomials. Again, like I said, product was a key word in this definition. If it's hooked by anything other than multiplication, it will not count. Pardon the noise in the background. My son is playing with his vacuum cleaner. Moving on, though. A monomial cannot have a variable in the denominator or be hooked by division. That rule also kind of goes hand in hand with the bottom thing that says that variables must have a whole number exponent. Again, technically, if we look at it in terms of division, if we wanted to make this one positive, we would have to move that base down to the denominator. So I could also write this term as 1 over x to the 1st power, which breaks the second rule as well. So again, it must be hooked by multiplication, and you cannot have exponents in your denominator. And then the other one that you look at here says a monomial cannot have a variable exponent. Other than that, you're going to be able to see a lot of things that are monomials, and then you're going to be able to put those things together with other monomials, which will give you polynomials of different kinds. So you can briefly look over these definitions here. Again, a lot of it is stuff that we've just talked about. The one thing I do want to draw your attention to, it says the degree of a polynomial is the greatest degree of its terms. And what that means is each one of them counts for its own thing. So when you count up the degrees of each term in a polynomial, the degree of the entire polynomial is simply going to be the greatest degree of an individual term in that polynomial. So if we look at this example down here, we have something in front with a degree of 3. The next term has a degree of 2. This term has a degree of 1. The last term has a degree of 0. A common mistake for students when they're asked what the degree of the polynomial is they will give me the answer 6. Well, you can't add them all up because each one of these monomials has its own degree. So in fact, the answer is not 6, but it's simply the degree of the greatest term in the polynomial, which is 3. And then if you look here, it says polynomials are usually written so that the exponents variable decrease from left to right. And so you would do it this way. Now, when other variables come into play, such as x and y in one polynomial, we'll do things a little bit differently. But when we're only dealing with one variable to a power, you're going to do it like this. So just a couple quick examples here. I'll let you guys have some time to try the second one on your own before we finish out here. But the first thing says here, write 15x minus x to the 3rd plus 3 so that its exponents decrease from left to right. Then identify the degree and the leading coefficient of the polynomial. So first thing, we have to write them from greatest to least. So my biggest degree is that x to the 3rd I'm going to write negative x to the third, so we have to keep that sign. The next one is at 15x, so I write plus 15x plus 3. Now that I've done that, I have to identify the degree. Well, the biggest degree is 3, we just got done saying. So off to the side here, we're going to put d is equal to 3. And then the leading coefficient, we can abbreviate LC. The leading coefficient is just the number that's out in front of the highest degree term. If we look at this one, it would be -1. Go ahead and take some time and try that second one, but before you guys are finished with this video, I just want to talk about a couple things here because it will be in your homework. A polynomial with 2 terms, it's just a basic term you should know, but it's going to be called a binomial. And then a polynomial with 3 terms is called a trinomial. You will have some in your homework that say to identify the polynomial, and that's what it's referring to. It'll say classify it by its number of terms, and so you'll call it a binomial or a trinomial based on how many terms it has. Now past that, we just call it a polynomial. You're not going to say it's a quadrinomial or anything like that, or have to, you know, figure out how many or what you would call something with 13 different monomials. We're just going to stop after trinomial and simply call them polynomials. But again, we'll try this next example right here by ourselves, and then we'll push into the lesson. Thank you.